Welcome you all. Myself Nagarajan, Assistant Professor in EC Department, Rohini College of Engineering and Technology. In this course, we will see about the embedded system and IOMT subject for biomedical engineers. The topic is a board support library. First, let us see the definition and purpose of the board support library. So, board support library is a collection of a software routines and drivers designed to abstract the hardware details of an embedded system development board. So BSL is nothing but it is a collection of software routines and drivers designed to abstract the hardware details of embedded system board. So the BSL provides a standardized interface to access and control the hardware components like input output pins, communication interfaces, timers and peripherals. So BSL it simplifies the process of developing embedded software by allowing developers to focus on higher level application logic rather than the low level hardware interaction. So let us consider the components of a board support library. So first components is a hardware abstraction layer. So it is represented as a HAL. So HAL is a key component of the BSL. BSL means that is a board support library that provides an abstraction of the hardware platform. So it defines standard API for interacting with the hardware peripherals such as a GPIO, ADC and timers and communication interfaces. The HAL ensures that the embedded application can be developed independently of the specific hardware details. A next component is a device driver. So the BSL includes device drivers for various peripherals and interfaces on the development board. These drivers manage the utilization, configuration and operation of hardware components such as a UART, SPA, I2C, PWM and Ethernet controllers. The next one is a startup code. So startup code is responsible for initializing the hardware and software environment when the embedded system is powered on or reset. So it step sets up the memory layout, configure the clock system, initializing the start stack and keep and perform other critical tasks before the main application code starts executing. The startup code is typically provided as part of the BSL. Our next component is a configuration files. So configuration files in the BSL define various hardware specific settings such as clock frequency, pin assignment, memory map and interrupt priorities. These files allow developers to customize the behavior of the embedded system according to the specific requirements of their application. Next components is a API documentation. So the BSL includes comprehensive documentation of the API is provided by the HAL and device driver. This documentation describes the functionality of each API, the parameter is accepted and the executed behavior. Now let us see the role of BSL in embedded system development. So first role is a BSL is a hardware abstraction. So the BSL abstract the hardware detail of the development board, allowing developer to write portable and reusable code. By using standardized API provided by the BSL, developers can easily migrate their application to different hardware platform with minimal code changes. And next one is a simplification of development. So BSL is simplify the development process by providing pre-written, tested and optimized driver for common peripherals. So it is a simplification of development. And next one is a platform independence. So platform independence means the BSL is to provide developers can achieve a level of platform independence, making it easier to switch between different microcontrollers. So or development boards. The BSL handles the hardware specific detail, allowing the same application code to run on different platform with minimal modification. And next one is a improved code quality. So the use of a BSL can improve code quality by ensuring that the hardware interaction code is reliable, efficient, and well tested. Next, what are the challenges we faced when we designing a BSL? Okay, so it has a limited customization, and next portability issues, and next dependency on vendor support. So limited customization means while the BSL provides a convenient way to interact with the hardware, it may also limit the level of customization available to developers. Okay, so portability issue means the BSL promotes portably across different platforms, and there may still be difference in the implementation of the BSL for different board or microcontrollers. And next one is a dependency on vendor support. The quality and availability of the BSL are heavily dependent on the support provided by the hardware vendor. If the vendor discontinues support for a particular development board or microcontroller, developers may face challenges in maintaining or updating their application. Next, best practice for using a BSL. So first we need to understand the BSL API, then leverage abstraction layers. Next, after that, optimization, performance, then stay updated. So understand the BSL API means developers should familiarize themselves with the API provided by the BSL and understand how they map to the hardware components of the development board. Next, leverage abstraction layers. Developers should leverage the hardware abstraction provided by the BSL to write portable and reusable code, optimize performance. While BSL provides a convenient interface to the hardware, developers should also consider performance implications, and also developers should stay informed about the updates and new releases of the BSL from the hardware vendor. And next, let us see the examples of a BSL using in embedded system. So it is the initialization of peripherals. The BSL is commonly used in initializing peripherals such as a GPIO, ADC, timers, and communication interfaces. Next, memory management. So BSL often includes memory management functions such as allocating and deallocating memory blocks, managing keep space, configuring memory mapped peripheral. These functions are critical for managing the limited memory resources in embedded system. And next one is a interrupt handling. So BSL provides API for configuring and handling hardware interrupt. Developers can use the BSL to set up interrupt vectors, enable or disable specific interrupt, and write interrupt service routines that respond to hardware events. Next, boot processor. The BSL plays a crucial role in the boot processes of the embedded system. It initializes the hardware, set up the clock system, configure the memory map, and loaded the main application code into memory. The BSL ensures that the system is ready to execute the application code when power is applied or a reset occurs. I hope that all of you understood about the board support library topic. So in board support library means it is nothing but it is a software routines drivers designed to abstract the hardware detail of the embedded development board. So thank you.